Hi viewers, I am producing these videos to support teachers of mathematics in helping their learners make sense of mathematical concepts and their associated procedures and processes. And today I thought I'd have a look at the column subtraction algorithm. And I've got my Dienes Blocks that are available over here to help me make sense of what's going on with this column subtraction algorithm. And you can use, obviously, with the physical manipulative, you can use the Dienes Blocks in 3 dimensions, and you can do that visually as well. I'm not going to be using the thousands block today, so I'm going to make those 2-dimensional just to make them slightly easier to sort of follow and look at. So with the column subtraction algorithm, there's a couple of different models for subtraction that can help make sense of this. So it kind of depends which model for subtraction that you're going to use. And we'll have a look at a couple of subtractions with a few different models, just so you can get a sense of which model you might best like and might best suit your learners. So if we start with a fairly straightforward subtraction, let's say 457 minus 233, then one of the ways I might make sense of this is to use a take away model for subtraction. So I might read that as 457 take away 233. Now, the take away model for subtraction is sort of not a great model for lots of different subtractions. There are some subtractions where it can be difficult to help make sense of using takeaway, and there is research that suggests that if students are stuck on takeaway strategies for subtraction, then they tend to be the students that perform less well in terms of, final assessments at age 11, age 16, age 18. But we can use a takeaway model to support making sense of this. So what I'm going to do is I'm going to build my number 457. So here's my 400s, my 50, and my 7. So there's my 457. And so the idea here is I want to take away 200s, 30, and 3. And because of the way I've chosen the numbers, it doesn't actually matter in this case whether I start by taking away the 1s and then the 10s and then the 100s, or if I start by taking away the 100s and then the 10s and then the 1s. It really doesn't matter with this particular subtraction. Of course, it will with other subtractions, as we'll see. So I'm going to proceed just in the sort of standard color algorithm. I have 7 1s. I'm going to take away 3 of those 1s. And so I'm left with 4 1s. I have 5 10s. I'm going to take away 2 10s. And so I'm left with 3 10s. I'm going to take away 3 10s, and so I'm left with 2 10s. Make sure I'm doing the right subtraction there. And then I have 4 hundreds. I'm going to take away 2 of the hundreds. And so I'm left with 200s. And so if we join all this back up, we can see that I have an area here, and that's kind of how we're modeling the numbers here, modeling the numbers as area. I have an area here of 224. Where it is important, of course, to make sure that we are following the algorithm in the correct sort of order from units up to tens and then to hundreds and so on, is where we have to exchange. And so to have a look at that, I'm going to have a look at the subtraction 457 minus 268. And some will argue that the column subtraction algorithm is not necessarily the best strategy for calculating this, particularly as 57 and 68 are relatively close together in terms of numbers. But if we were going to model this as a column subtraction algorithm as a takeaway, then let's have a look at what that would look like. So we would start again, similarly with 400 and 57. And now I want to take away 268. Well, if I start with my ones, and this is sort of why I'm starting ones here, I can see that although I want to take away 8 ones, I don't have enough ones to take away because I only have 7 ones. So what I can do here is I can exchange that 10 for 10 ones. And there we can see the 10 ones that I've exchanged it for. And this is kind of why, it makes sense to start with the ones, because if I'd have already evaluated how many 10, if I've already started taking away 10s, then I wouldn't have any 10s to exchange. So now I'm in a position where I can take away 8 of these ones. And so we can see now that what I'm left with is 9 ones. And in effect, what happened here is I exchanged one of my 10s for some ones. So that went from me having 5 10s to me having 4 10s. And because that 10 became 10 ones, when I combined those with my 7 original ones, I had 17 ones. And so now I was in a position to take away not 8 ones. So I've taken away 8 ones, and the result is 9. And then we're going to see a similar thing here with the 10s and the 100s. So I have 4 10s. I would like to take away 6 of those 10s. However, I don't have enough 10s to take away. So what I'm going to do here is I'm going to exchange that 100 for 10 10s. So this now leaves me with 300s. I've got a bit of overlap in there, but this leaves me with 300s. And I've exchanged one of my 100s for 10 10s. I'm just going to correct that overlap. I've exchanged one of my 100s for 10 10s. And so now, instead of having 4 10s, I have 10 plus my original 4. I have 14 10s. And so now I can remove 6 10s from there. I can take 1, 2, 3, 4, 5, 6 10s away. And of course, because I had 14 10s, the result is I'm left with 8 10s. And then with my 100s, I've got no such issue, thankfully. I have 300s. I would like to take away 2 of those 100s, so I can just take away 2 of those 100s. And you can see, if I were to connect it all together, that I'm left with one single 100, 8 10s, so 80, and then these 9 1s, and that's the area, the total area that I have with this shape. So this is a reductive model, a takeaway model of subtraction, and it's one of the ways that we can make sense of what's happening with the column subtraction algorithm. Potential alternatives then are I could use a difference model. So if I just go back to the first subtraction and set up my 457 again. So there's 457. I could compare that to 200. So here's 200 and 33. And I could look at that and say, well, in this number, this 457, how many more ones do I have? How many more 10s do I have? How many more 100s do I have? So we can see that if I compare the ones, I have 4 more ones here than I do there. If I compare the 10s, I have 2 more 10s here than I do there. And if I compare the 100s, I have 2 more 100s here than I do there. That gets slightly trickier, though, if I want to use a difference model where exchange is required. Because if I now look at this as 268, so that's going to get me up to 263, and then I copy some more in. So there's my 457 and my 268. Then I can see that, okay, well, I've got 7 here and I've got 8 here. So I've got 1 more here. And what does that look like? And how does that work? So if we're going to use a difference model, then either we have to adapt the algorithm or we have to make it explicit that there has to be more of each thing in the first number than there does in the second. So I'd have to do an exchange to make that happen. If we were going to adapt the algorithm, then technically we could adapt the algorithm to something like this. And say, well, there's 1 more here than there is here, so that is -1. And then there's 1 more here than there is here, so that is -1. And then there's 2 more here than there is here, so that's 2. And the idea being that if there's more in the top than the bottom, then the result of that digit subtraction is positive. And if there's more in the bottom than the top, then the result of that digit subtraction is negative. And so from here, I would read it as having 200 minus 10, so 190, minus 1, so 189. And this is called point-by-point digit subtraction or place-by-place digit subtraction. So we just subtract the digits in the place and we're allowed to use negatives there, which obviously works quite nicely if pupils are familiar with negative numbers and using negative numbers. But if pupils haven't been introduced to negative numbers before being asked to work with the column subtraction algorithm, then it's not necessarily going to work out particularly nicely. Like I say, we can use a difference model to arrive at 189 through the standard column subtraction algorithm, but what we'd have to do is then say, well, at all points there has to be more here for each column than there is here. So then I would go about doing that exchange and say, right, well, now I have 17 ones compared to 8 ones, so I have 9 more ones here than I do here. And then having to exchange my 100 for 10 tens, I would say now there's 14 tens here and 6 tens here. So there are 8 more tens here than there are here. And that's left me with 300. So there is 1 more 100 here than there is there. So you can make that work, but you either have to put that stipulation in with the manipulative. And of course, the manipulative is about helping to make sense of. So if you're having to stipulate how that manipulative is going to be used in that sense, then it might not be a particularly useful experience for learners. Or you can make it work using digit by digit subtraction, but it's, again, if they've not met negatives, it can be a little bit sort of tricky to work with. The third potential model is to, and I'm only going to model this with the second calculation, 457 minus 268, is to actually employ a model for subtraction which simply defines subtraction to be the addition of the negative. So here I've got my 457, and here I've got my 268. And so I'm saying is if I want to subtract this from that, then what I need to do is make this into its negative. And I can do that with this by multiplying by -1. With the actual physical blocks, that can be harder to see because they can't make them different colors, or they rarely make them different colors like I can do here. But I can multiply these by each of these by -1 to make it into its negative. And then I can proceed to treat this like an addition. Once all these things are negative, I can treat it like an addition and say, well, I'm going to add this -8 to this 7. And when I do that, I will start creating some 0 pairs. And we can see that we're going to be left with 1, -1. And if we allowed it to sit like that, then actually what we'd end up with is this second result of this calculation, this 2, -1, -1 in our column places, because we'd have a -1 sat there. We can get around this, of course, by again sort of stipulating that there must be no reds left or no negatives left. So in order to get rid of that negative, if you like, I'm going to exchange one of these 10s for 10 1s, and then I can now create the 0 pair there, leaving me 9 1s. But again, we're having to make that stipulation into how they're going to use the manipulative. We're having to add that rule in. So if we are having to add that rule in, that might be, it might open up questions there with learners about why we're having to do that. But from there, of course, I can proceed as I have done previously. I can see that if I now start creating 0 pairs here, because I now only had 4 10s left, I've now got -2. Of course, I would have an extra 10 if I hadn't done that exchange, but now I've got this -2, so I'm going to have to exchange that for that 100 for 10 10s so that I can create those 0 pairs, leaving myself with 8 10s, and then I can simply create the 0 pairs out of the 100. So in terms of what the column algorithm is designed to sort of do, it's probably designed to work with a takeaway model, in that you must have enough to take away, and that prompts the need to exchange. If you're going to use a sort of difference model, or the changing a subtraction into addition of the negative, then you are going to need to stipulate those things that we talked about, either that there must always be more in the top number than there is in the bottom for any column, so that we have to, motivate that exchange for the comparison purpose, or we are going to have to stipulate that we must never be left with any reds, in effect, any negatives, and so we have to exchange in order to make it positive, unless we're happy to actually amend our column subtraction algorithm into this sort of result. And if we're happy to amend it so that we're allowing negative results within each place, then obviously either of the other two models would theoretically work better than a takeaway model. But of course, this requires learners to be, relatively au fait with negative numbers, and the idea that 7 minus 8 will be -1, or be able to see that with the representation. So that is my shortish video on the column subtraction algorithm, and how we might use manipulatives and images to support with pupils making sense of that. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for providing such a wonderful website that not only houses all of these virtual and manipulatives, but has got a wealth of other material on there. And if you've never been on mathspot.com before now, then I heartily recommend you check it out. You will not be sorry once you get into all of the things that it has to offer completely for free. And if you're interested in using manipulatives in general to support the teaching of maths, then I would also urge you to visit my website, visiblemaths.co.uk. And amongst the things you'll find on there, you will find a link to my book, Visible Maths. Visible Maths is the title of the book. The publisher is Crown House, and they, on their website, which is linked on my website, you will be able to see sample pages. And if you think it will be useful, you can place an order. I'll be making these videos at least through lockdown, I would have thought, if not potentially beyond. So if there is a video you'd like to see, if there's a mathematical idea you'd like to see sort of explored with manipulatives, then please do get in touch, and I will do my best to create one for you. Thank you very much for your kind attention today.